In this video, I would like to address some common errors involving correlation. We're gonna discuss 4 errors in total, and the first one is this. It is wrong to conclude that correlation implies causality. Um, for example, it was noticed that in City A, there was an increase in sales of ice cream. At the same time, there was an increase in the number of shark attacks. Now, our question is, does the ice cream sales cause the shark attacks? Because they are increasing. They both were increasing at the same time, right? Now, I hope that you're answering no, the ice cream sales do not cause shark attacks. In fact, the increase of both of those variables was caused by another increase in another variable. We called it lurking variable. In this case, it's the population of the city grew. So grew the ice cream sales and the number of shark attacks. I have another video that I created about this type of error. I'm gonna link it somewhere so you could watch it if you're interested. Now, the second common error is extrapolating your data beyond the range of available data. So here's an example. We collected the data about the age of the cars and the corresponding price of each car. And we created this chart shown here that shows a linear correlation between the age of the car and the price. As you can see here, we have the oldest car in the data was 7 years old, and the price was what's the price? $48,000. Now, if we were to extrapolate this data, like continue this line, then eventually it's gonna hit 0. In fact, it's gonna hit 0 probably like around the age of 8 or 9 years years old for sure. Now, does that mean that the value of the car will reach 0 when the car hits 9 years of age? And of course, the answer is no. This pattern will change. It's probably going to flatten out as the age of the car increases. So we cannot assume that this pattern will continue as is beyond the age of 7. Okay, so next. A regression equation based on the old data is not necessarily valid now. Here's an example. We collected the prices of Honda Odyssey minivans in 2005. Of course, they will cost differently now. And the prices of maybe uh, new line of Honda minivans is going to cost differently. So that data does not apply today. Another example, if you're studying gaming habits of teenagers and you have data from 2002, of course, it's not going to be valid today. The gaming habits changed significantly since 2002. And number 4, don't make predictions about population that is different from a population from which the sample data were drawn. So for example, if we analyze the proportion of broken pedestrian walk buttons in the city of Chicago, it does not apply to a different city, such as New York City. So those are our most common errors, 4 of them, and that concludes our topic of linear correlation and the common errors.